All right, thanks for coming. As of 2 minutes ago, it's too late to vote, but I hope you guys all voted. If you can, let's get started. So, a couple announcements, some which you'll like and some which you won't. There's obviously midpoint presentations today. There is no lecture next week because next week's lecture is during the midterm period, and so we want you guys to go take the midterm. But on Sunday, we will have like an hour or 2 hour long midterm review session. It'll be in this room, and we'll put more details on the outside. It's optional; you don't have to come, but it's a good place to get some of your questions answered. For that, homework 6, the test files will be released today, so you'll get to check your answers for that, and we'll have the audio run and stuff like that. And then we'll have an optional extra credit homework 7, which will be released sometime this week, and then that's going to be extra credit, and it'll be due at the end of the semester. So you don't have to worry about that. But it's a good way to, I guess, get extra credit if you need it. All right, cool. So with that, let's get started. The Midpoint presentations, how this will work is there should be, I'll put a list up of the order. But we have UIUC Hitch going first, and then I'll control the slides. You guys will have about 4 to 5 minutes. Try sticking to 4, and then we'll have 1 minute for audience questions if there are any. But yeah, all right, that.
Hey guys, my name's Aaron. This is Sudesh Shah. Our PM is Karthik, and we are UIUC Hitch, a better transit app. So something that we all do every single day is commute. And there's so many problems with the way we commute because all the apps require us to compromise between different features. Like all the transit apps that use CUMTD's data can be very accurate, but they don't provide like ease of use because you have to memorize every single transit like location, and you can't look up like where you want to actually go. And then with Google Maps, you can look up where you want to go, but the times aren't accurate and it's hard to understand what it wants to actually do. So something that we wanted to build was an app that would bring both of these features, accuracy and ease of use, and on top of that, some extra features. So we wanted to add some scheduling because commutes can be very regular, but we have to look up like a transit every single day. So we wanted to make like a Google Calendar for your transit that would automatically tell you when to commute. We wanted to have accurate times, and also this intuitive layout that would just allow you to look up either your station or your specific building where you want the window.
In terms of accuracy of data, we're going to get the data from the CMTD API, which gives it gives real-time GPS location of each of the buses and gives an estimated time of arrival. Although something that they don't offer was the head count that we mentioned before, and so we plan to try to see if we can get enough users to make this useful enough. But the main feature here is using CMTD API and getting more accurate data, arrival times and putting that and integrating that into Google Calendar so that you don't have to switch between two apps or waste extra effort trying to connect to databases together. Basically what I just said before, the main feature of our app is going to be connecting Google Maps and DCMTD real-time data because for some reason they aren't connected currently. Compared to like my hometown over in California, which actually does have the Google Maps is actually integrated with real-time transit data, which is really cool. So we want to try to do something along those lines. And then a little bit about the integrations we want to do with like with Google Calendar and other things would be, for example, if you had a schedule like this, we would use that probably the Google Calendar file of some sort and parse that and allow you to figure out exactly when to get on a bus on what day based on either historical data or like the static database that we're given, so that you know exactly what time to get on a bus regularly and throughout the day.
Cool. So the main crux of our tech stack for this web application is Flask. That's what's going to handle the full stack of both the front end and the back end to make calls to the CMTD API that's publicly available. The back end, the data will be stored on MySQL database probably. And then another API that we're going to be using in order to make some of this stuff easier for us to actually be able to practically get location or routing from one location to another is Google Routes. That's a publicly available free thing that Google provides to be able to do like shortest trip or based on time and stuff like that. And then on the front end, we're basically just using HTML5 templates to make it look pretty. Yeah. So for the minimal viable product, realistically what we're trying to get done here is make something that looks decent on the front end. We need it to look clean and easy to use. We want something to be simple. User goes there, is able to automatically have their current location, find the location they're trying to go, and then get directions pretty quickly. Live updated data from CUMTD, and then being able to search locations intuitively, so you don't have to put in like Goodwin and Springfield, you can just put in Siegel, stuff like that. And then displaying bus routes for accurate times, and showing the bus routes on a map and locations and stuff. And that's all. Cool, thank you. Awesome. Yeah, any questions?
All right, Easy Week, you guys are up next. One down, and then I think it's Ed VR, the Wild Cooker. You guys are after Easy Week, so get ready.
Hi guys, our project is called Easy Week. My name is Rishikesh. Rohan, Alex, Zach, Arvind. So our project is a web application which allows students to find appropriate classes and fit them to their schedule. And we would take into account how many credits a student has and would recommend genets for them to fill their schedule. We would also take into account like distance between classes and help them predict begin with a better schedule that is more realistic for students.
So for our project, we're using the UIUC API to access all the courses and their timings. And along with this, we're using Flask to integrate all the courses and display them on our webpage. And along with the courses, the API provides us prerequisites and a description about each course. And all of this will be displayed on our webpage while the user is able to add their courses to their schedule. So we'll be using a server to get an input from the user and store our data. And the input is used to build a specific URL for the user to use.
So we have some more next steps. We were going to demonstrate, but essentially right now how we have it set up is we have basically Flask implemented so we can do post and get calls from the API, the Course Explorer, so we can organize various data or organize that into a Python class. So essentially we have methods set up so that we can call different aspects of information about each course. So I guess our next steps are essentially to use this data and organize it more on the back end to find basically to generate more of a schedule using factors such as the distance from the classes, suggesting stuff based on the times. Can you go back to the next step?
You can use the Google Maps direction API to calculate the distances between classes so that we can factor that into the scheduling of classes. That is something we can do.
There exists a UIUC Open API which already has a lot of data stored in it, which we can use to not just generate genet recommendations, but also the distance portion. We're going to analyze the existing genet datasets to basically take an input from the user saying these are the topics we're interested in, and then say top 5 recommendations for genets. Also factoring those out according to what the existing technical courses in the schedule are. I believe you're supposed to laugh.
Guys have any questions? How are these memes? How bad are these? No, just kidding. Good try, good try, good try. If you really like a meme, laugh out loud and we'll know. And we'll keep track of the ones that like. Good try, guys. Alright, Ed VR, you guys are next.
So we are EduVR. So what EduVR is trying to accomplish is making physics concepts more tangible through virtual reality. So what we're going to do is not only we can isolate different variables so students can get a better sense of what specific physics concepts are, and we can also display data like vectors and stuff so people can get a more intuitive sense of what courses are at play.
we are up to right now is currently we're exploring a lot of the technology associated with VR, and our main component will be the headset, which we are developing using the Oculus Rift, which is a very popular solution currently. And eventually we are thinking of moving on to more accessible solutions that's cheaper. For example, like Google Cardboard, that's like you can put your phone, display the simulation in your on your phone with like specialized glasses. And we also have to facilitate user input. We got like touch sensors and IR sensors, and also our code is written. We're currently developing in Unity and using C# as our programming language.
So we spent the majority of our time working on this project, getting our bearings with Unity and learning C#. C# is pretty similar to Java, and programming in Unity, it's not so much typing out code as it is learning the interface. So in that regard, it's kind of like mobile development. And like we spent some time acquainting ourselves with VR, which is kind of like another way of saying like we just played a couple games, like see how VR works. I mean, yeah. And then we created a couple of the initial physics demos. So we're like working on kinematics and forces right now.
Okay, so essentially this is the environment of Unity that we're using. So you can see the three different, or you can see all the different views. So that's the top view, that's kind of like a bird's eye view, and then the side views. So basically you create assets and then you can drop the assets into the environment and then manipulate it using the C# script we wrote.
Next up, we have a YouTube video demonstrating some of the stuff we've done so far. Okay, so here we have a basic like playground to block around. So right now we're using keyboard controls to toggle the different things. So this first demonstration is going to show how we can turn off and on gravity. Because Unity has a lot of this stuff preset, all we have to do is just say for the specific object in the script, turn off gravity, and yeah. So there we go, the gravity acted on the object. Okay, so now we're going on to the second object, and this is showing the different forces that we can apply. So both of these objects have inherent masses that we can program in Unity, and one is half the mass of the other, but they're getting the same force. So this shows that one of the balls is going to go much faster than the others. And the way we can move them is we can just add a vector to it, and then that just makes one, since there's the same vector, one goes much faster than the other. Okay, this final demonstration we have is showing the collisions. So this one is just an inelastic collision, but by changing the properties, we can change what kind of collision it's going to be. So this one's going to collide into the other and slam into the other. Do we have any questions?
No.
Oh wait, there's one more.
So that's mostly where we are right now. Some of the ways we want to expand is increasing the interactivity of these demos. Right now it's just pushing buttons, but there might be more ways we can expand that. So yeah, touching, grabbing assets, and we could also expand the number of physics demonstrations we're doing beyond inelastic collisions and other things. And there's other educational things we could display, like things like chemistry inside of the cell and biology, stuff like that. Any questions?
pedestrian detection. Guys are up next. Slides.
Okay, so our project originally was pedestrian detection, and that's the name you'll see up there. But actually, as you're about to see, it has kind of evolved past just pedestrian detection for self-driving cars to being kind of the software for the self-driving car as a whole. We'll get into that later, but right now we'll just talk about what we've done so far. So the original plan was to use this feature extraction called the histogram of oriented gradients. And basically what it does is it just takes like the gradient of the image at various pixel values and normalizes it locally. And it's a feature extractor for a learning mechanism, learning model such as the support vector machine. And as you can see there, we have actually implemented the support vector machine to try and filter out not only pedestrians, but also vehicles. And Thomas will talk to you a little bit more about that.
Okay, so here is our demo. So the green boxes here is our pedestrian detector, and it's a video that I take in here UFI. And the blue boxes are the vehicle detectors, and it may produce some false output. Yeah.
All right, so next we have a video on the highway. So what you can see here is we're drawing lines for the lane detection. So it draws both the left and the right lanes. So as you can imagine, that's pretty important for self-driving cars. And then you can also see that we're able to detect vehicles with the blue boxes, not only from the back profile, but also from the side profile as well. And then you can also see that sometimes the boxes are a little bit off when there's two vehicles kind of right next to each other or passing. So that's something we could work on. We'd have to find a data set kind of specifically for that in order to kind of apply our techniques to that arena.
So here are some challenges we are facing. So as you can see in the demo, our FPS, which is frames per second, is very low. It's like 3 FPS. And in order to do like real-time analysis, it must go to the 30 FPS. And we are using SVM right now, and we have not enabled the GPU acceleration. So we probably going to use neural network and enable like NVIDIA GPU to accelerate our computation. And we also have some false detections. We are going to improve our algorithm and to reduce those false outputs.
Sorry, can you go back actually? So then our kind of end goal is like, all right, if we're able to detect these objects, what can we do with it? So we want to implement a GTA simulator that's able to kind of, you can self-drive a car around the GTA kind of universe. And then be able to, the car will be able to detect people, be able to detect vehicles or stoplights. And then we also want to apply some simple motion planning in that context. So what that means is if a person's walking this way, be able to say that most likely that person's going to continue walking in that direction at that speed. And then finally, it's great that if you can detect objects, but then you also have to do something about it. You know, so it's not enough to say that, okay, there's a pedestrian in front of me, and then keep driving. You know, so we have to implement something where it says, okay, there's someone in front of me, and then hopefully our vehicle will stop. So I don't know if we have time for questions, but this is our main. Thank you.
Cool. Event detection. Guys are up next.
All right, hey, my name is Akil, Eric, and that's Manchu, and we are doing event detection.
Okay, so originally this project was called Camera Mesh Network, so it's for detecting crimes. Since it was a pretty complicated project and we had a relatively small group, we decided to make this into a smaller project. So instead of creating like a mesh network, we just focused on doing event detection. And also instead of detecting crime, we switched to detecting soccer events. So the reason for this is there's not a lot of like high quality crime footage publicly available to use for training. And there's a lot of like soccer footage like on YouTube and other like public resources. And the soccer footage is usually like pretty consistent. It's like a pretty general view. And yeah, so like some of the events like we're focusing on is like detecting cards and like goal scored.
What are our ideal goals? We have 3 ideal goals. One is we should be able to detect objects, such as the cards and the ball. And we should use these objects to be able to detect events. Ideally, it should be able to run at a clean 60 FPS. So this is what our timeline looks like so far. As you can see, we've been doing quite well and sticking to it. In September and October, we're talking about mainly our idea, and that's when we actually decided on soccer and started looking at the rules. And then starting like the past 3 weeks or so, we settled on the scope and have actually been working on detecting the objects. And then we're going to start training the algorithm on Amazon Web Services this week. And then we hope to be done recognizing events by the end of November, and then just fix all the bugs in the beginning of December.
So in order to do this event detection, we're using the YOLO algorithm, and YOLO stands for you only look once, which ultimately optimizes for performance as well as accuracy of an image. So this allows the image detection to operate up to 100 times faster than RCNN. And just to implement some of the tools we're working on, we wrote a YouTube image video scraper and trimmer, which allows us to put all of our videos and training footage into a JSON file and then easily download and scrape it. And then we also wrote a Getty image scraper, which was surprisingly easy to get past the copyright filters. So there was that. Yeah. So. Oh, and if you want to see the resume of the guy who made YOLO, yeah, that's it. Like, that's a real resume, and it's phenomenal. So, in light of that, we are going to rename our group My Little Event Detection. Yeah, there's that.
So continuing on our current progress, so Darknet now is the pre-trained YOLO network made by that person already detected soccer players and balls when we ran it on some test samples. However, it didn't detect like yellow cards or red cards, so we needed to retrain it to include those. So we labeled around 1,800 images, and we're currently training that on the AWS EC2 instance. So this is a picture of us labeling. This is like the bounding box labeling tool. You can see the yellow card in the box with the yellow card label. And this is a screenshot of it training.
Alright, so we're just going to demonstrate really quickly how easy it is to get past Getty images, like watermark, and then just download a bunch of images. So we wrote this really simple script. like
The slide presentation doesn't show it.
nope, I just But basically, if we run a script, we can download like literally thousands of images in like a couple minutes without watermarks, which we could very easily get. So, yeah, that was a good time.
Questions, comments, concerns?
Yep.
All right, Safeways, you guys are up next.
Hey, hello, can everybody hear me? Alright, so our project is called Safeways. My name is Melissa Chun.
I'm Kathy. I'm Hannah.
William.
Alrighty. Okay, well, actually just a basic info on Safeways. So basically our goal is to create a web application that can show the safest routes from point A to B, accounting for crime within the area, and also not only crimes that happened recently, but also places where crimes happen with a very large frequency.
So this slide basically shows what you'll be met with when you open the app. So it's a map using the Google Maps API, and there's like 3 different modes of transit. There's walking, driving, and busing. And you can enter a location and it'll like show you a route from where you're currently at, so it uses your GPS, to that place that you entered, and it'll give you directions on this like right panel over here.
So another feature we're working on implementing is displaying alternate routes. And so we'll display a total of 3 alternate routes, and we'll be using those routes and comparing them with the locations of each crime, and basically seeing which ones, if any, are safe for the user to use.
So I was told to put stuff on the slide, so I did. Basically what I've been working on is just doing the styles for the CSS. You can see the top bar. That wasn't on the previous 2 slides because the pull request hasn't gone through yet. But yeah, that exists. And, I've also made an about page. I'm still working on it, but this is it so far.
So I worked on the server code, so it's all written in Node.js, and it basically takes in like latitude and longitude coordinates from the back end and sends it to the front end, and it's good, yay.
Alright, so what I've been working on is the data parser. So basically, the University of Illinois Police Department has an API where you can take crime data, and it gives you all sorts of information, like where it happened, when it happened, who responded to the scene, what type of crime is it, stuff like that. And so you're implemented given something at the very top like that, but that's just really messy and difficult to deal with. And so as a team, we decided that these crimes listed at the bottom are considered to be severe crimes, and the ones that we definitely want to map on our web app. So then, using my data parser, I was able to filter through like the specific types that we wanted, crimes that happened recently. Next slide. Also, I was also able to count the number of times the crime happened at a certain place, and by place I defined it as like a 1-block radius. So if like 10 crimes happened in a 1-block radius, you probably don't want to be walking there at midnight on your way back from Granger. And ultimately, we came out with 2 different CSVs. So the top CSV talks about like, oh, this is where crimes have been happening recently. And by recently, we as a group defined it as the past 6 months. And then at the bottom, it's like the list of all the coordinates of where crimes have been happening with frequency. And then we assigned to it also a number called the danger level. And the danger level is just a measure on a relative scale of 1 to, I think, 10 of how often, like how dangerous that place is based on how often crimes have happened in the past 7 years, which is all the data that we can get from UIPD.
Okay, so the way we work with this is we get a CSV file and we parse it into a 2D array, and we basically use that array to display a marker at each crime location.
Okay, so we encountered a lot of challenges when we were working on this problem. So the first one is that we were having some pretty big difficulty finding an API. So the problem with the one that we're using right now is that it only updates every day, and it only updates with data that's 2 days old. So we're never going to be able to get the most recent data, and that's what we struggled with when we were looking for an API, because we could never find something that was super recent. Also, it was difficult to process a large amount of data. It took a long time for the script to run. And then turning the file into a 2D array on the front end was also really difficult.
So what we're going to work on next is we're going to check if a path crosses through the crime, so we can tell you to avoid it, like we've been planning all along. And then we're going to add a better description under each marker of what crime that this area will pass through. And then we're going to improve the general interface of the site and get a nice server going for you guys.
You guys have questions? Okay, awesome. Good stuff, guys. UI traffic as your.
So, we're UI traffic. So, inspiration, you ever have a time where it's like 8:45, you're trying to get to CS125 at 9, and then you go to the Ike, and this is what you see. Literally everyone trying to get on the one end, and you just, there's no way you can get on, right? And they're like, all right, let me wait like 5 minutes for this. But then for the 10, and you see the 10 pass by, it's just full of people. And by this time it's like 9:02, just like, I'm just gonna go back to my room, sleep, screw this, right? There's gotta be a better way to do this.
Hey, hi, I'm Jackie. So what if we could know the busiest locations on campus, but in real time, but also ensure that the data is anonymous? Like, you don't want to be going into the app and like, oh, okay, I see where this person is, let me go there. That'd be pretty bad. And so what we're working on is an app that offers possible new routes from location A to location B, as well like the best time possible to go there. Okay, so what we have is a pretty basic website hosted on AWS, and that can get data points from our database and displays a map using a Google API.
Okay, cool. So, yeah, so how we are currently doing this, so we have our app, right? The app is the main portion of this, and a user who's using or wants to use our app would have our app, right? And periodically, your location would be anonymized and broadcasted to our database, right? And as a user, you can then view the aggregated data of all the. Okay, cool. Anyway, so you can view all the data of all the people around for a specific time period, and using that, you can kind of tell how crowded a specific location is. And we still need to work on this, but we will perform analysis on the data to classify a specific latitude and longitude coordinate to a specific location. So we can classify this location as feeble or dining halls, bus stops, and all that. And as well as we have our website, which would show all the data across all time, where you would be able to scrub through time and see trends in our data. So I think we're gonna move on to our demo. Oh, yeah. So that's an example of how the website would look. So it would be a satellite view of the place with a heat map of showing how crowded the location is. So this was just some example data, but it would be like that. You can kind of see how crowded a place is. And as for, I guess, once that loads, okay, a bit better, but this part is kind of so I could pull up my phone and check. You can kind of see at the top right, that's where we are right now. You can kind of see it's a bit more crowded. Since it's only us right now, we don't have lots of data. The idea is lots of people have the app, or more people who have the app, the more accurate this data representation would be. So that's us here right now. I think that's right now. So crap ton of people here, so you know that this place is crowded, or more crowded compared to other places. And if you scroll across the streets and stuff, you can see which places are less crowded. And yeah, that seems like a bus stop or something over there. Not as much crowd. Cool. Right over there you can see the bus stop. That's our dining, our hall, living hall. So yeah, you can kind of see which places on campus are crowded or not. And with the more and more people who have this app, right, you can kind of see how, say, if every person on campus had this app, you could easily see which places were really crowded and which places were not. So, so what we're trying to add, right? So it's pretty basic for now, but.
So what we're trying to add is a cleaner looking user interface, as well as turning the dots into a heat map, because right now it's kind of just ugly black circles. And showing the data by time, so you can know at which time the place is the most busiest, and classifying the locations into places, for example, Seawell, the Union, places around campus, and finding the trends in locations using data analysis to find what times each place is most busy, and having a navigation feature that could give users the most efficient route from point A to point B.
Okay, that's time.
Okay, cool.
I really need to step up the meme game. Okay, alright. This is for everyone, not just you guys. Okay, alright. Music app. You guys are next.
Hi everyone, we are working on the music app. My name is Prayana.
I'm Anna.
And I'm Jonathan.
And our PM is Grace. And so we're first going to explain the motivation behind this whole project. So imagine that you just got back your midterm grade and now you want to use it, listen to music for therapy. So you're probably in a bad mood. But now imagine you're listening to a sad mellow song like Hello, and all of a sudden the Despacito trap remix comes on. So playlist generators, like those found on Spotify or other platforms, don't really take into account the emotions that music makes you feel, whereas emotion is definitely connected to music in a very deep level. So what we're trying to do is create a service where users can classify their music not just based on emotions, but specific things that they associate certain music with, so that when they get a playlist, they get something that's suited for their needs.
So we're going to talk about the features of our music app. Can I have the next slide, please? So searching. So we are going to create a series of tags for you guys to filter through, such as party songs, sad songs, and then you could search through these filter tags to access songs more easily because, yeah. And then we also have a special portion which is the personalization of the music app. So users can create their own filter tags. So like, for example, I could tag Let It Go as a happy song, and I'll just play it on my, when I'm really happy, I can just search for my happy songs and Let It Go would pop up right in the beginning.
Okay, so our process is pretty straightforward for tagging. First, for a specific song, we'll create a tag. And it could be user-defined, or it could be pre-existing, like maybe party or something. And then we'll save the tag for future searches. And then later, when the user logs in, they can search for the tag and see all the songs under that tag. And we're also pulling a lot of data from Spotify so that you can connect all of your playlists from Spotify to this music app. So our product so far, we have a home page, and we have a login page.
So the rest of our tech stack is we're using Firebase for storing user data, as well as React for our general web app. And so once you get to like the user dashboard, there's a quick select playlist there's a quick select menu where you can just click whatever emotion you're feeling at the time. And these are like user defined boxes. So like say you have like a nostalgia playlist or doing CS homework playlist. As soon as you click it, it would automatically generate a playlist for you that has the songs that you tagged under those categories specifically. So yeah, and if you don't want to do any of those specifically, there's other options. So you can look at popular lists by other users. You can create a new playlist, or you can go to your previous playlist and see what you've listened to before.
So that was our minimum viable product. So this is what we hope to achieve given more time. So you could link up with your friends with different accounts. You could share songs, share tags, etc., and interact with through each other, kind of like a Facebook type thing. So yeah, that's our slide. Any questions, comments, concerns? And the next slide is our meeting.
I like this. All right, let's get into plans. You guys are.
Hey guys, so my name is Jackie.
I'm Fizza.
I'm Shannon. I'm Damon.
And we're Scan to Plan. So basically the idea behind our app is it allows the user to scan event information, say on a flyer or on a PowerPoint slide, and the app automatically creates a calendar event for them.
So the first thing we did was the camera portion of the app. We used the AV Foundation framework, and then we have the front and back camera working. And we also implemented like where you can upload from your camera roll, and it displays the picture on the screen.
For the text detection portion, I used Firebase, which is Google's mobile app development platform. And from that, I used Google's MLKit text detection API. So this was one of the bigger challenges to get running because like the model, it only accepted like images in a certain format, but that's all good to go now. Oh, and then Fizza here, she did our UI design, so like the color scheme and the logo and everything.
My contribution to the project was extracting date, time, and location information from text, and then being able to create an event on the user's calendar.
Okay, so some of the challenges we faced. First of all, we spent the first couple of weeks just trying to come up with a good project idea because our project manager did not like any of them. But it was all good. We like him now because he's been solving all of our crazy merge conflicts that GitHub has been giving us. As you can see over there, he has stayed up quite some nights trying to fix all of the mess that we've made with GitHub. But I think we've kind of got it under control now. Some of the problems that we've had are just kind of understanding Xcode and Swift, because I have definitely not had any experience with that. Damon over here is a PC user, so he's had to do some fancy stuff to try to get that working. But yeah, so far, I mean, most of the problems we've had have been pretty solvable.
So features that we have left to add, the first thing is the natural language processing portion of our project is incomplete. So what we still have left to do is extract a possible event name and description to add for the event. And then another thing that we'd like to add is integrate with Google Calendars, because right now what we have is we can add an event to one's calendar on their iPhone only.
So for our demo, we are going to be, so there's this event coming up called Mamma Mia, which shameless plug you guys should all go to. But so this is a poster that you can see around. It has all the information like when to go, where to go, all that kind of stuff. So what our app does, so once you open it, loading screen opens. Our camera's a bit funky, so it takes a bit. But you open the app and take a picture, and it detects all the text that there is, and it creates a calendar app, which once you add it, then you can check your Google Calendar, and there it is. Ta-da!
And then our meme is right here.
Any questions? All good.
Barber, you guys are up next.
All right, we are the Barber team, and next slide. So Barber is the app that we're working on. the idea of it is it'll just give you hairstyles and haircuts based on your facial features.
Yeah, so these are just a couple of the mock-ups we came up with. So on the left we have what a login screen would look like, and ideally we want to connect like Google login, Facebook login, stuff like that. In the middle is kind of like where you choose or upload an image of your face, and then on the right would be like how you fill out the form where we collect data like hair length, and then the different options would be like short, medium, or long.
Alright, so first we got a huge database of like pictures of haircuts organized by different subcategories. So like he was saying, we're going to have a selection for short, medium, or long because you can't get a long haircut if you have short hair. And then we organized it by like hair type. There are 12 different categories of like hair curliness, and we like sorted all of these pictures in Firebase.
So basically the way our app works is we have a database of very good looking haircuts. And then we then use an advanced face similarity algorithm, which takes your face and then searches our database for someone who has a similar face type as you. And then we then recommend the haircut based off that.
Okay, so some challenges we've had so far. We initially started developing in React Native with the end goal of having an iOS and an Android app. Sadly, that didn't pan out because we couldn't connect it with our Firebase database. So we had to scrap all of our React code and then transition to Android Studio. Kind of a bummer. But once we got that all working, it'll be a better app in the long run.
And so as far as the backend challenges, as Sean said, we had some issues with populating the database when we were working with React. But since switching to Android Studio, we've started to make much better progress. And so now we're able to store images in our database, and we're now looking into how we can retrieve those images in order to run our facial similarity algorithm and determine haircuts.
All right, so in terms of some future goals, so basically by the end of the semester, we just kind of want to get a working product done where you can take a picture of your face and we populate like the app with a bunch of recommended haircuts. And in terms of after that, what we kind of see this going into is it could also be a platform. We might try and contact like certain barbershops. So it's a platform where they can post their pictures and they can get marketing that way. So these are pictures that they've gone. And then you can go and look at pictures that these certain barbershops have given and then maybe implement like an upvote downvote system. So you have like the best haircuts in the like places around you so you know which barber to go to. And here's our meme.
I'll get my revenge, I promise. Good beat though.
You're looking like a snack, bro.
Alright, finite state machine generator. Next.
Hello, my name is Aman.
My name is Wade.
My name is Adam.
Evan.
And before we actually get into our slides, I'm just going to start with a bit of our origin story. So originally we were called an English decoding language, and the goal of that project was to basically turn English code into Python, English like text into Python code. And it was meant to like so people could have like an easier transition into CS. Because most people, they struggle with understanding the syntax. So it was just meant to like, target people who had a rough time understanding the syntax. So like that turned out to be really hard. So we decided to, we still wanted to make a useful utility. So we decided to do find a state machine generator.
which finding states of machines are useful because you can use them to model like any function. So for example, if I wanted to model mod 2, like if I wanted to get the result of 7 mod 2, which, I mean, most of you guys already know the result is going to be 1. But what you basically have is like 2 nodes. A 0 node and a 1 node, okay? And you would start with 7 in binary, which is 1, 1, 1, okay? And this is how the nodes transition to each other. So if I'm in the 0 node and I see a 1, that's when I transition into the 1 node. And if I'm in the 1 node and I see a 0, I transition back to 0. But if I'm in the 0 node and I see a 0, I stay there. Yeah. So you just start with the most significant digit, which would be 1. So I'm in the 0 node, I see a 1, and I would just keep staying there until I get to the least significant digit, and the result would be 1. So that's just a really simple example, but you can use that to model, like, let's say a refrigerator or a vending machine. Like, that's what we're trying to do.
Okay, so for the actual DFA. Okay, so DFA is a state machine, and like one input gets you into one out, so one way. And like the way we do it with like language processing, like you can input that would be numbers, alphabets. So the way it actually works is like what the mod just.
So the way it works is you have a starting state or a starting node, and then depending on the certain keys you have transitions, you might switch to other nodes. And then typically there's an ending node, like a list of accepted nodes, where if you end up there, you end up like getting the accepted state, which is what this would be aiming for, depending on what the task is. So, for example, you would start off at Q0, and then if you were to pass in 0, 1, 0, it would go from Q0 to Q3 back to Q0. And let's say the accepted state is Q0, so that statement would be accepted. And then you could have as many different transitions or as many different alphabets that you want. You could run some code I wrote up right now, but I'm not sure if you have time, so we might need to move on.
Okay, so this is going to be our process. So what we wanted to do is just design a website that would help just do what we just said. So our website is basically a banner, a console, and a canvas which projects the DFA. So as you can see, you can easily tell which part I just copy pasted from Bootstrap, which is the top part. And then in the console you can just type whatever you want.
So as for the way the actual program is going to work, the entire basis of it is that the user would type in a string of any sort in order to have some kind of action or to interact with the DFA. So for example, they can type in create a node titled 1 and it would create a node titled 1. And you can also create transitions and also different accepting states and other kinds of things. So first we take the command from the website, and afterwards we would take the string and process it on our server using our regex, and then process it into a JSON file which is described with DFA. And that DFA would then be projected over to the user so that they could see how it works on their front end.
Once the JSON file is sent back to the website would just analyze the JSON file and create a DFA projection, put it back on the screen. This part is one of the things we're working on right now using P3.js, and that's been one of our challenges, is learning P3.js.
Okay, cool, awesome. You guys have questions or? Yeah, any questions? Okay, we're clap. OpenStreetMap, whatever, building section.
Hey guys, we're OpenStreetMap Building Detection. I'm James.
I'm James.
I'm Brian.
David.
I'm Jonathan. I'm Jonathan.
Okay. First of all, what is OpenStreetMap? OpenStreetMap is a collaborative project to create a free editable map of the world. And right now, the process of adding buildings to the map is manual, so you have to click on each corner of the building, and that can take a lot of time. The aim of our project is to turn this into a semi-automatic process, so the user only has to click on a building to add it to the map, so they can add entire cities in much less time than before. The first thing we had to do is we had to get some aerial imagery to analyze. And fortunately, there are some companies that provide OpenStreetMap contributors free access to their data sets. So the first thing we had to find is how to download these tiles and how to combine them together.
So first off, we tried doing a contour plot to detect buildings. This contour plot found different color variations and plotted a contour map right on top of each other until it got a map that found where buildings are not. So basically this helped us find this sort of region where the building is, but it didn't find the building. A better approach was using hue lines. Hue lines basically take a vertical and a horizontal gradient, and it cuts and makes a line outlining the building. This works most of the time, but it's not going to work without some person checking how it works.
So our idea for this algorithm is to basically extend these hue lines until they intersect, and then find the nodes where they intersect, and then from there we can map the building.
So along with our algorithm side, we have the front end page, and the front end consists of a login and create account page. So upon creating a valid account, you're able to access the Google Maps API portion of the website where you can type in any address you want, and you're able to retrieve an image of a quadrant and then send to our algorithm to be analyzed.
Alright, so I did the back end. So there's like two main, or actually there's three, but we've done two so far. Two main parts to the back end. The first end was interacting with the OpenStreetMap API. So they have a nice dev server for you to mess around on, which is exactly what I did by accident. So it took a little bit of a while to figure out because it's not very intuitive. But over here you'll see at the point 1,1 on the planet Earth, we have this box I made approximately 50 times if you look at the left. That was a bit of an accident, but oh well. So if you go to the dev server right now, you would see all the changes I made. And then on the right, you'll see that 1,1 is right next to Africa. And that little orange dot, that's me. I did that like 50 times. But yeah, that's there. So that's one thing the backend does. It'll take a bunch of nodes with latitude and longitude, and it'll plot the coordinates. So if you feed the corners of the building, it'll plot it. So that part's ready to go. Now we have the database side. So we're going to have users like Vic just mentioned. So there's databases. A lot of people are talking about SQL. I'm going to trump all of them and tell you guys about data set. So this was made by a bunch of trolls that wanted you to not learn SQL. You can see their graphic right there. But basically, you can just do SQL without using SQL. It's like JSON. So it's really, really nice. I would high-key recommend this. I think, yeah.
So we have a demo here, so just as James and Brian said, so we wanted to create something where a user would click and it would automatically map the building. So you can see here, and it does that building in the center building, but there are some limitations to our code right now because you can see the building to the left has like a line running through the middle of it, and the building to the right has a bunch of black lines in the building. So for the future, we hope to basically make our code better and take care of these different conditions. Any questions?
Enjoy our memes.
Cool. Auto calendar, Azure next. Everyone wants the same exact thing. application format?
It's the best one.
It's the best one, okay.
We are the team on Auto Calendar. I'm Will.
My name is Miles.
I'm Shreyas.
I'm Eric. So our concept was to make an application, any type of application, that would allow you to log into your email, and then it would parse your emails. And you can parse your emails, and then from that it'll determine events, and then it will display like the events it found, and then with that you can add them to your calendar and modify times and dates and who's going.
So initially we had a back end and a front end, and so our back end was like a server where we would save user data, and but we later scrapped it because 3 of our members dropped from the group, so it was just me and Will just working around, and that was not working well. So we got 4 more people, or 3 more people, sorry, and a new PM. So that was much better. And then now we're using a lightweight flag server to run a parse on emails, and using some natural language processing to define times and locations. And then on front end we have an Android app that supports email selection and link to Google Calendar.
All right, so here we have some demos.
So this is the first page, and here we have account login and password and go, and we will see some parsed events that are listed here. And once you click on it, it will show like a bunch of events from a same person, from the same person, and you can also further click on it to edit it. And then you can click on the checkbox and then choose which one to add to under. And this is where we are right now, and there's more we're going to add to it.
Alright, so our first problem was finding out how to use the Gmail API system. And so we looked up different tutorials on how to use it, and did a lot of videos, and then they had a couple of online implementations that we just screwed around with that, and we created our own email to use. And then we found a couple of methods that Google has provided us in Java, Python, and many other languages that we can use in our app. And then building an API instance is also our current problem, because there's a problem on that. Yeah.
And then just as far as the back end goes, some of the issues we faced are just getting like optimizing time and accuracy, because a lot of the parsers, especially what we're doing, are very time intensive and storage intensive, and we would like to get the data to the users as fast as possible. So I guess. So what's next is, so we want to link the data output from our parser to the Google Calendar API to create events in the user's Google Calendar, and then also incorporate the backend Python server so we can analyze emails. And finally, we want to fully integrate all those things together into our Android app. Any questions?
The reason they had no memes is because they were all okay. Pixel.io. That's great.
Alright, so we're Pixel.io. I'm Mark, this is Eunice, Ethe, William, and Anoop. So we were one of the wildcard groups, so we spent a significant amount of time figuring out what we actually wanted to do. No one really had any significant idea. So we played around with different ideas such as data analysis, finance, education, but we settled on making a game. And then we didn't know how to do it, so we first started playing around with a Python solution with Flask, and we found Pygame, but ultimately we settled on Phaser, and that means that everything that we're doing is done in JavaScript.
And so what did we actually decide to do? And what we wanted to do is make a game basically that was single player. We interact with other players on the web server that we would create basically. And we had two components. You have your own territory, and the purpose of the game is to get as much territory as you can. And we also have a path, which is what the player is on. As a player gets more area that's not its own, it increases the what it has. It increases the area it's have, and it interacts, and it basically is against other players that are trying to either kill them or get their own territory. And we can see here the different shades of color. So we have to decide how we differentiate between the area and where the player is.
The way we implement the game is really simple. We're running a JavaScript server with Node.js, and then the way we communicate the client and the server is through the socket.io, and then we use the Phaser as a game engine on the client side, as well as the server side. So it's pretty straightforward.
So once we have our minimum viable product down, we want to make it ultimately a multiplayer game. And from there, we're thinking about adding different game speeds and different game modes, adding power-ups on the map, and maybe different skins for each path. And one of our final, if we finish very early, we have an idea to implement it onto a map API and make it like a running territory app instead of you controlling an actual player, where you would be the player running on an actual map, taking over territory, competing with other runners for territory, like a running motivation type of app.
Alright, so as my partners have mentioned, we spent a long time brainstorming what we wanted to do. So we really haven't started actually working on it till recently. But so far we've laid down the foundation. We've done the basic, like setting up the board and stuff like that. And we've just learned a lot about various packages we're using, such as Phaser and Socket. Does anyone have any questions?
I feel pleasure next.
Woo! Let's start clapping. Thank you. I feel famous. Like it. Thanks.
Hi. I'm going to guess none of you remember what this was, because we spent the first 2 weeks reminding each other what our project was. But let's get started. So I feel the greatest project to ever grace this great auditorium. It's literally just a social media app where you can communicate with people through very limited subsets of emotions, and then either they reply or a bot does instead, because honestly they just wanted the validation for how they're feeling anyway, and why should you have to spend time giving them that? Let's rock and roll. So, in terms of technology, we made the decision, some might call it unfortunate, of using React Native because it's cross-platform. Of course, something's only cross-platform if it works on any platform, so that's kind of tough. What else are we using? We're using Firebase in the back end. Other people have already mentioned that. Basically, it lets us do authentication very nicely and abstracts the database stuff. We've been using something called Expo that lets us very easily load the thing onto our phone for building. And in terms of the chat component, there's a library called Gifted Chat that handles a decent amount of like the actual networking part of chat stuff. So that's going to be, that's what allows us to do that part. And then last but not least, our bot. We haven't really gotten that far yet, but we'll figure it out.
Alright, so when we were looking at the challenges dealing with Firebase and as well as using React Native in general, at the start we kind of conglomerated all our navigation pages into like one app.js file. And we definitely worked on that by splitting it up into different components, which you guys will see in images later. When we look at the front end, it's just, in terms of navigation, the actual feed, it was tough to understand React Native and how to build like a visual representation of what we were doing. So one kind of issue is, some of the issues we're dealing with, Grant actually pushing the API key to GitHub, but so that was just kind of a small issue, but we've been working on that with using like a .env file to hide that API key and put it into gitignore, but it's kind of weird because React Native uses some sort of functions in order to pull that variable from external files and use that API key. So it's just a matter of actually getting used to React Native, which we weren't very good at. We weren't very good with. And then the rest was just simple, like small stuff. So like using or merge conflicts and things like that, where we're just messing around, not like mixing our ideas together properly. And especially with splitting up work, like I mentioned at the start, so we kind of put all the components into one page, which made it a lot harder for us to work with, but once we split into components, we got that going a little better. And then online, there's obviously a lot of tutorials with React Native, but with our project, but especially with things like authentication and such, when we try to like put those things together, it's just kind of, it was tough at times to get those things running, but they're just kind of small issues that we've been dealing with and debugging as we go.
It's fairly self-explanatory.
This is just the way that we distributed our work. It's kind of what we covered.
Yeah, so this is basically just like what our app looks like. So we set up the login page, just put in your email, password, and then just a button to log in. And then this is just basically all the different files, code, all the functions are in the next slide.
So this is what we plan to do, like based on what we have so far. We still need to create like a message page and a group page and a sign up page, and then like make sure we connect the front end with the back end. Most of this is gonna be like the pages part are pretty easy since we already have like a login page. We just need to like carry that over to the others.
Ta-da!
UI chat. I like these memes.
Okay. So, warning, Undertale spoilers for neutral and genocide routes. If you haven't played the game, you're gonna have a bad time and should probably close your eyes so you don't get spoiled. Grant, this may or may not include you. Next slide. So, We are UI chat, which I localized hopefully okay as the Yixin. So this, if you don't recall what that is, that it began when, scroll down, and IQ decided to hit that, hey, UIUC has too much stuff going, and we should unify it all in one thing, preferably that's also a chat app. So basically, what I finalized as the thing that is going to be happening is a chat app that integrates completely with all UIUC services is going to be the limit as t goes to infinity of this app. So, unfortunately, Android Studio hates me. It will not compile, and it is not exactly clear on why. It may have something to do with the fact that the app and the UI are split across two different Git branches. I honestly don't know. But, so, minimum viable product. There's a saying in the gaming community that says that the problem with games today is the minimum viable product is a rough beta. My minimum viable product is a fully functional chat app with, at the very least, basic UI system integration. Scroll down. So, here's what we got done. We have the entire framework on the client side. This is what is going to be storing things that are encrypted by the encryption package, which I did not include on this for lack of time. And this is what is going to eventually be uploading things to our remote server. Scroll down. We have part of net.uichat.ux, which is the user interface that is probably causing my compilation errors. Scroll down. And then we have some of the APIs for my Illini. This meme, in case you did not know, is a screenshot from Aliens Colonial Marines, in which an alien completely fails to notice you even exist. Scroll down. Of course, the problem with all this is, look, a 3-meme combo, is that the build keeps failing, and we don't know why. Okay, so we can probably make a chat room, push messages to it, and integrate with my Illini. Scroll down. But we don't know if we can do that because our IDE sucks. Before I turn over to questions, do you three want to do little follow-ups?
We are using Flask as our backend, and we finished the database that contains like 2 models. The first model is for the user. It contains the basic information for the user. And the second model is for the message. It contains like message body and who sent it. So.
I'm one of the backend group. We are using RSA system of encryption decryption for our message in our chat room.
Quote David S. Pumpkins, any questions? It was just Halloween, so that meme is appropriate. You.
How many days has it been since Halloween?
6. Thanks. Anyone else? You look like you are poised to ask something. Okay. Vivek, here's the mic.
I couldn't turn the volume down anymore. My bad. I got it. worry about it. You guys are nice.
Probably can't beat that, but okay. So, big as a boy. I'm Pranav.
I'm Hugo.
I'm Allison.
I'm Wilson.
John.
So basically, this is just an app which helps you find new friends and in an intelligent manner, as opposed to the way of actually talking to people. So yeah, so we'll just start talking about our specifics right now. So.
Okay, so I worked on the authentication, and we basically did that by, we used Firebase and OAuth to host that. We started with a basic app that allows the user to sign up for our app and then log in. And this gives options for Google or Facebook, so you don't have to create a new account. You can just log in with Google or Facebook. Some of the challenges I faced while working on this, we used React Native in order to be able to have our app be on iOS and Android, but that means using JavaScript, which I was not familiar with, so I had to learn that. There was also some problems getting the emulator working, so once we had tutorials to work on with the code, we also had to be able to test it with the emulator. And then a challenge that I foresee in the future but have not dealt with yet is connecting the login to the rest of the app so that you can see more than just the welcome screen.
Okay, so for the friend recommender system, initially we tried to use K-mean, but we realized that K-mean doesn't work with categorical data because we use like the user majors, career, movie genre, hobbies, which doesn't have any number to compute. So instead we use K-mode instead of, so basically the algorithm counts the mode of each attribute for each clustering.
And then all challenges that we have faced so far is that we don't have initial data, so we cannot test our recommender set system. And then we are still finding a way to make a certain attribute to be more important than others because, for example, we think majors is more important than music genre because we think people with same major will have the same common than people that have same music genre. And then the last thing is that because we're dealing with categorical data, all the differences are the same. So, for example, we want to match more junior to senior because we think they have more things in common than freshmen.
So for the messaging portion of the app, I also am using Midpoint Chat as a previous group. It's like a library that helps make the framework for the UI. I'm also using Chatcat API to store the messages into the database. And I'm trying to create like a scrollable interface so you can see all your message conversations. So the challenges I've faced are like trying to integrate the Chatcat API into my app has been kind of difficult, like learning JavaScript because I know for this. And then finally modifying the chat UI to fit the overall UI of the app so it all looks nice.
So I just built the database and backend. So initially I was working with React Native and Firebase, but I had some trouble with that. So I decided to simplify it and just build a simple Flask web server and used Heroku and Postgres to communicate. So we just store all of the data that we have. Like the app interacts with the server, which interacts with the database we stored on Heroku. So initially we had difficulty with React, but yeah. So switch to that. Questions?
Yes, God.
Hi, so we're Tastebud. My name is Shri. This is Vish. This is Claire. So our app is basically like a dining app that links like users with rankings of like food items in the par dining hall. So the way our app works is first there's a we need to retrieve data from the users. So this is done through questionnaires that ask users about the quality of the food and like with data like the rankings. This data is then stored in a MySQL database, and there's then a backend which is the creation of rankings of the food items for users to see through like a website. So currently we've done we've stored data and we've created the ranking systems, and we have a basic website going. So that's what we have right now.
So our login page is pretty basic right now. We use Material UI components to do like the top bar and the username and password text fields. And the thing about Material UI is that it's really easy to just add them to your JavaScript. And we're using React to do the login page. And Material UI works really well with JavaScript, so you don't have to manually code all the components.
So this is sort of a mock-up. It's actually a running website, but it's sort of the basic outline of what we're doing right now. So these card elements, this is part of the Material UI library. These card elements, they basically are things that you will be able to interact with, highlight how many stars you rate that item, and we want to make them sort of responsive and dynamic based on the device, so you should be able to use it on a web interface or on your phone. And the cards, the plan is to make them size corresponding to how well they're rated. So just to make it sort of a nice, like, visually pleasing interface like that.
And as for the challenges, we are in charge of storing the data from users, and also like we try to parse the data and try to rank them in the back end of the database. So in our app, we try to use the PHP, and by providing some interfaces, we can first fill out our requirements, and then we can also account for edge cases, which means that we can adjust rankings if only a few users input ratings and feedback. And we can also like handle the user passwords, which is a part of the backend and the JavaScript functions. So next slide. And for our future goals, we aim to use the ranking algorithm to find the ratings instead of a simple a weighted average. And also we can give users some better recommendation. And also we can give the consistent, it's like consistent design that's usable across the mobile and the desktop. And the last is that we can provide the easy sign, like the sign process, which can, it's like we try to provide this more convenient way of letting the users like see what they can like log in. So it's our future goals like for our app.
Whenever I ask people more knowledgeable about me, about what IDE to use for Python, they always just say no, use Notepad. I was like, how do I like check for errors and stuff, so I'd always get errors. But yeah, any questions?
Answer.
Hello? Who here likes to listen to music? Raise your hand. I'd expect that more than just half the room likes to listen to music. When was the last time you were sitting there, bored out of your mind in a doctor's office, looking around, trying to figure out, what can I do? But all you hear is silence. We here, aspiring developers, part of the ACM concert team, are trying to change the world. We want to bring joy back into these offices. And we're doing this through ACM Concert. This is the new redesigned version of the ACM music or player distributed system that we had in place years ago.
All right, so basically, we ideally will be on 3 different platforms, web and on 2 different cell phone platforms. And so we started out with a not so nice web front end, which we are redesigning now, and we are working on new apps for mobile. And then for backends, there were a ton of bugs. A lot of the integrations weren't working. We have to work with 3 different systems for our different songs, so it's just a lot of different bugs, and we're working on that. And specifically, we want to add Spotify. Yeah.
Yeah, so we started out with our the UI that we have right now. We made that in HTML and CSS, so that was just like how we wanted to make it. But then after we did that, we realized you want to put it in React to make it a React application. So that's a process we're going through right now, as well as we want to redesign it. So that's where the wireframe comes in.
Yeah, so initially the concert UI was a little bit boring and pretty plain. So as you can see in the redesigned wireframe, we kind of rethought the UI and are in the process of redesigning it. So basically we looked at music players like Spotify and Google Play Music, and we saw what we liked and the similarities between them. And right now we're in the process of implementing that wireframe that you guys see on the screen right now with a really cool cover art in the background. And yeah.
So some things that we've done so far. SoundCloud now works very smoothly, and Concert essentially runs on a server right now in the ACM office, so we did a lot of tinkering with starting it up on the system startup using systemd. We refactored a bunch of old code because it was not that clean. We integrated with LastPass a bit just to make it a more seamless auth experience. And for us, we created a dev mode so we can bypass all of the auth when you are running it on your own machine. We reduced some things that we rely on, some dependencies, and we patched a security bug.
Okay, so the next steps are figure out a framework for Spotify, because the current Spotify API only lets you listen to songs for 30 seconds. Right now we're exploring an application called Mobity. We're going to integrate the new UI with the backend, make sure it all works and everything. And then we're trying to add playlists and queues, and also add like a historical record of songs, just so we can like analyze what are the most popular songs people like queued up on concert and everything. So, yeah.
There's also one file integration we're planning on making, and it's to make an immutable record of all the songs that were played before. Our big data team has been working hard to try to get this working. We plan to not only make this work for playlists, but to other fields in the future. And some of these fields could involve distributed currency systems as well.
I don't know what to say. This is just kind of randomly put, but it's a meaning to me. Q has a question.
So, when you say a security hole, how bad was it? On a scale of can attack anything on the network to can rickroll without authorization, how bad was it?
I'm not sure what you mean by rickroll.
As in, insert songs, unwanted songs into the queue without authorization?
I just don't know, man. They shouldn't have said it.
Walk away.
All right, cool. Squad up.
I'm tired, you're tired, let's keep this short. Now, what's the biggest problem with us CS majors here? And the ECE boys, they're known as the stinky ones, right? What are the CS majors known as? We're lonely, right? Yeah, we are very lonely, so we made an app to counter this.
Our project aims to bring people together by helping them find people nearby to meet up for social events. So we'll help people find others, but in a friendly setting, not in any other setting. So our aims for the final product were a little bit too much, so we wanted the geolocation tracking. We'll probably be able to manage that, and user profiles, that's possible too. Doing those error-free will probably be impossible, and yeah, I just added the name-based part to give CS 126 students PTSD. Yeah.
So some of the challenges we've faced so far is being able to integrate all three parts of our project together. We have a back-end Firebase, Google Firebase for our database, and UI front-end. And one of the bigger challenges was being able to like pull data from the database through all of our applications.
Now we're just going to do a quick demo of our app. Alright, so just going through basic on how it looks. This is how the login page looks, real quick. And that's the sign-up screen, and moving on. That's just an example of creating an account and logging in. And that's our database once we update the application. So we're going to show a live demo. So let's just sign up, create a new account, email abc@gmail.com, password 123456, 123456, and we're gonna create a real quick account. First name, let's see, Vivek. And then we're gonna upload a really quick profile picture. And then we're gonna hit save, and that's gonna create our account. And is in default groups right now. Is in like the nature squad, sports squad, and the food squad. Those are just cards. You could later on click on it, and then the chat box opens up. So if we like kind of swipe from the side.
What we've got so far as functionality is we've linked up all the parts. So we have, for example, we have a Flask backend that does our logic, and so if we have one function, for example, that takes from Google API the geolocation of the phone and compares it to our database of users. And I've seen flash up on the screen, there are 2 strings that came up as a toast message. Those were users that were within a certain physical range to your phone. And so that would be what we can help use to suggest nearby users or groups that we
And so basically, in essence, you guys might like question what's different about this app than like other social media apps around. And we kind of want to show the importance that we show groups and like mainly squads around you that you could join. So if you move to a new place and you don't know anyone or anything, easily search and you can be part of a group. With other apps, it's just more about talking one-on-one, dating, or just moving apart from that. So are there any questions?
Already broke? Nice. Full disclosure, this is Allegra and my group. So we'll see what needs these guys have.
Hi, I'm Yathar. This is Nicholas, Harshit, Jason, Nate, and Chirag, and we're broke. So why broke? Before coming to college, I was talking to my dad, and he said, keep a database of all your finances, keep track of where you're spending your money. That made sense, and I was looking for a platform to, make this possible, and I didn't really find anything. So what did I do? I opened my notes app and I created a note with just list of transactions with my cash, with my first card, second card, and that seemed really cumbersome. And I was talking to other people as well, and they told me they had the same problem. They were creating Excel sheets and none of this was efficient. So when we were supposed to make a project and solve a problem, I thought about this and thus came the app Broke, which is ironically named to help college students not be broke. Now we have Nate and Chirag talking about the API implementation.
So our app, we used React Native to be able to get to a wide user base of people, because I mean, you all have phones, right? So we used an API called Played, and that API basically allows us to connect banking account data to the app so we can sync transaction data and stuff like that. It's used by a bunch of different companies like Venmo, Citi. It's really widely used and supports pretty much every major bank there is.
So we established a secure connection from our application to Plaid's interface, and this is an encrypted connection because we're handling financial data and we don't want to have any unauthorized access with it. So none of the user-sensitive data can be accessed by our application as it's encapsulated by Plaid's interface. And what we do on the backend side is we periodically pull transaction data, such as bank balance or where you spent money recently. And this is the data that's used by the graphing and analytics team to perform certain functions in the app. So now we have Jason explaining how the JSON files work.
Hi everyone. So basically my job on this project was, wait, can you go back a slide? You're kind of ruining my joke before I even got to it. But, so basically my part in this project is taking the JSON files that I get from the API request and then turning it into a format that the graphs can process. Basically we're using a graphing library as well, so it needs to be in a specific format so that the graph can actually be graphed. And at first this was a little bit intimidating because I didn't know how JSON worked exactly, right? So it was kind of a new thing. So, but then I realized programmers love JSON, and JSON is a much better way to store data than CSVs that sometimes you have to clean up a lot. So then I learned to get to know JSON a bit. At first a lot of my friends made fun of me because my name is Jason, but I didn't know JSON. So it's kind of problematic. But then I realized if you want to pick up programming, I don't know, partners, you got to know JSON because all programmers love JSON, maybe even more than Jason. So.
So after JSON filtered all the data from JSON file, the API team parsed
we got all the required categories, and after that, I used that data with the React Native SVG charts to give it a vector representation, and it basically gives out different sorts of graphs with numerical data, and we basically chose this library for it's so that it basically provides us with the freedom to customize its style, and so that we could make it look attractive, and that's all.
Alright, so here's a quick overview of what we've done so far. So this is our app currently. Well, right now it's still just a bunch of placeholders. This is the main screen. This graph isn't actually anything, it's just a placeholder once again, and this is the categories, still placeholders. We'll be changing it once we get the actual data. This is just a blank screen where we'll put all the graphs that Jason will make, and this is the budgeting screen, of course, still empty, because we haven't gotten all of our parts connected yet, because we all have our own dependencies, and when we try to merge them, everything just crashed. But we did get the API connected to the app, and it works just fine, and we can try it out. Alright, so this is my account, and we need some confirmation. And there we go, it's connected. Of course, we don't have anything more than this because we haven't connected with the graphing team. And yeah, that's our app right now, and here's a bonus meme. Any questions?
All right, policy, that's your next.
All right, so I'm Tom, that's Harrison, this is Lee, that's Chris. I'm just kidding. All right, but yeah, this is everyone, and this is policy, so this is our presentation, and we're gonna talk about it. So what is policy? We kind of went over this before, we pitched this, but yeah, basically just collects tweets about political candidates. So right now we have an election going on, so if our thing works, it'd be pretty cool to like analyze that, but you know how that goes. So yeah, currently we currently just kind of look at gubernatorial candidates. That's just like governor elections, stuff like that. So we collect the tweets, we calculate the sentiment, so it's like positivity, negativity surrounding that candidate, and once we have that, we provide like graphs and visualizations of our sentiment to the people who go to our website. So
for the front end to represent the data that we had, we use Chart.js, which works with React. It basically allows you, if you can see at the top of the code, to import different kinds of charts, like line charts, bar graphs, pie charts. So we decided to go with a line chart because we wanted to show data over a certain period of time. And what Chart.js allows you to do is also customize a bunch of things like the way the lines and dots look and the type of data that's represented. So far what we've made is a working chart that's going to give you more of a general, and you'll see in the next slide, more of like a general chart. And then when you mouse over different points, it's going to give you more specific data about each candidate. We're collecting data about tweets for each candidate. So in the future, we kind of want to play around with Chart.js more, see the kind of customizability that it has for aesthetics, making it more user-friendly. We want to make it more detailed, probably, like talking about positive and negative tweets versus just number of tweets and popularity. And just make it more interactive overall and see what Chart.js really has to offer.
Okay, so this is a sample of the kind of chart we'll be looking at later. So this is Mr. Chuchu, who many of you know from CS125. So this is basically a representation of 1 week worth of tweets we found online. Now this is not accurate data, but it's pretty simple to feed data into the code you saw in the previous slide. And as you mentioned, you can see me mousing over the point there, which gives me more detail. So, and we're also looking to provide more detail per candidate in these charts.
All right, so we basically use two main things. So we use, what's basically just one thing really, it's Tweetbee. So Tweetbee is a Python module, which basically lets us like call the Twitter API through Python, so it's pretty handy, because that's basically how we get all of our tweets. Some challenges, so I basically tried to like get some data from some guy, but he charged me $200. He was like, hey, pay me $200, like it's my student discount. So I kind of like took the tweets from his website, which probably wasn't good, or like the handles, so yeah. And then like Twitter's API isn't too good if you don't pay for the actual like paid API access. So it's been a challenge, but we're pretty creative. We got the top minds here, so we're struggling through it. And our next step is improving our database. Right now, it's just some kind of weird like combination of JSON files and CSVs, but you know, one day it'll be pretty. So and also improve the send algorithm. So yeah. Here's some pictures of JSON files, CSV files, and a little bit of code with the URL of the website that I scrape things off of, write it out. Meme break. All right, so here we have, I don't know what the hell that is in the middle, but we have a real screen cap of my private DMs with Aiden talking about this goofball right here. So he's actually gonna fail the course. So unfortunate, he's dead weight, according to Aiden. So.
It's not hard. Basically, I'm responsible for the server part. We use the Flask and the React.js. Flask is to build the server, backend, and React.js is to create the interactive user interface, work with the front part, and also we use the JSON file that Thomas had for the data part, and basically we just get the Flask work with the JS part, just have the sample, but it doesn't work with the data Thomas got.
There's some server pictures. Okay, click it again. All right, thank you. I tried. So for the front end, we just use HTML, CSS, JavaScript, React, and those boys over at Node.js. For all that I've done so far, it's just I've made boxes on the website, and the boxes can show and hide information, and then using CSS for style. And what we plan on doing next is to implement the charts into the boxes and actually displaying all the gubernatorial information inside the boxes. And that's about it. Yeah, the boxes aren't very interesting. That's all. Sorry.
Thanks.
Okay, server sickness detection. I'm Harv. Vishnu. Louis. Jason.
Yeah.
Yeah. So basically, what we have so far is that we have a basic Blast website and a React website. And we also have some basic working algorithms to detect malaria, leukemia, blood cell counts. So we can detect white blood cell counts and red blood cells counts in individuals, small sample of blood. And then we use Python and OpenCV to do this. And then we're also working on building a threshold detection, so it can tell you if you have stage 1 cancer, stage 2, depending on how many of those cancer cells you have in that small sample of blood. And then we're also building a faster RCNN model with the MIT's blood image data set, and we have a basic model of it working so far.
So we also have a website right now. This is kind of what it looks like right now, and pretty much just displaying, we pretty much just using it to display the results for some of the algorithms we've written for different diseases. So you can see on the sidebar, we've written some to detect malaria, HIV, leukemia, sickle cell. This page is for HIV, and it just has a little blurb of information about the disease, how we try to detect it, and then the results of the algorithm running on a small blood sample.
So these are a few examples of our results at the beginning. So here we were just using OpenCV to basically detect blobs. We have multiple constraints like the radius, the how circle it is to implement the algorithm to different disease to find out how many cells there are in the picture, and based on that number, we determine if there is a disease present or not.
So this is a new version of the blood cell detection code. Now we can detect blood cells which, and after using a 18,000 image data sets from MIT and taking some bloods from people we know after we built the device, we've been getting pretty good results, and you can see it now.
So by the end of this month, we plan to have a model and a website and an app. And for now, we're just focusing on building the device, and we're trying to enhance the device so that we can run efficient algorithms in the live setting. But that's about it. And that's our view. That's our view. Thanks.
I'm surprised, where'd you get that second picture from? It's not on Facebook. Of course we did. Okay, cool. Not cool, but sure. Instant notes. You guys are next.
Alright, we're Instant Notes. This is Seth. I'm Gautam.
I'm Anish. I'm Rajat.
I'm Megan.
Oh yeah, so far we've made a functional app. We call that our minimum viable product, emphasis on minimum. It can take pictures, send them over to Google. Google will tell us what text is in that image, and then we save that text for the phone, to the phone. So do we want to see a demonstration now? So we just start by taking a picture of the notes. It pulls up the camera, which right now there's nothing. I'm going to take a picture of just some text right here. The power button. There we go. So it shows us the image. We're going to hit OK. It gives us a preview on the screen. And we have the option to run it on the cloud or not. We currently don't have an API key that has a credit card loaded up on it, so we cannot run the cloud, but the implementation is all there as soon as we do get an API key for Google that has a credit card. But we run the text recognition. It shows us all the text that it recognized. Of course, hopefully I have a less shaky picture. That may have been part of it, and some of the streaks on the screen maybe played a part. But that shows us all of our text right there. And then if I go to the Android files, of course we would have a way to pull this back up within the app. I can go down to the app files. And here are documents. This is the most recently taken one right here. And that shows us all the text that we just took a picture of.
So this is, again, like Seth said, the minimal viable product. There's still a lot of stuff that we want to do with it. The first of which is what I'm working on right now with the Firebase, and that's user accounts. So we want to be able to personalize this experience like we talked about in the pitch. And the best way to do that is to save all of the data to specific user accounts and then use that in the training of the users so we can adapt our model to each user. In addition to that, we also want to do some kind of cloud support with this. Like Seth showed, we have to go into the phone and drag out the text file. Rather than doing that, we want to be able to export directly to things like Google Drive and iCloud.
So one of the main challenges that we've been facing so far is that when we recognize text, we have a huge long blurb of just handwritten text. And once we start using machine learning to create a neural network that will recognize that text, we run into the problem where when you recognize a letter, you get a higher chance of success versus when you recognize a word versus when you recognize a sentence versus when you recognize a whole paragraph. So we have to figure out some way to put up our input text into either words or letters, which will give us a higher rate of success in recognizing them.
Yeah, we also need to work on image pre-processing. As Seth kind of mentioned in his demo, the image he took was kind of rough, so we want to be able to a little bit better. Also, one of the goals we had was to have formatting in the output. So we want to be able to recognize white space and add it to the document or the output of whatever we take a picture of. So that's stuff that we still need to work on, and hopefully we can get done. Any questions?
If there's a group that we haven't called out because you don't have slides, you raise your hand. Anyone that hasn't had a chance to visit work? Okay, cool. You guys are the last one.
Thank you. I'm staying. A group stick task is basically an assignment for it. So this is front end is reality right now, but that's basically what I'm going to be working on for the next few weeks. You can add an item at the top. Then there's a bunch of tasks that you have that get that are listed in priority based on our algorithm, which we'll explain later. There's a calendar at the bottom, which actually will explain, and there's a sidebar where you can select if you want to restrict it to a specific category, like only 196 assignments.
So I worked on the back end. So basically there were two functions that I had. One was to give a priority, and the other one was to insert an array of priorities. So these three things are schemas, or test schemas that I made that are priorities, and the numbers are how important each of those topics topics are. And then over here is the console log, those three schemas. And as you can see, fish has the lowest priority, and it's all ones mostly, and then dog is next, then cat. And then I'm going to be working on in the future, like user schemas, and so when new people log in, you can store their information in like a database.
So I tried making a login page. So like it's not like I have like basically a function for like when you sign in, but when you're actually signed in, and then of course you have to sign up, and then bottom is the actual code for the function. You guys are not shown because long.
Yeah, it was basically adds an event to the user's Google Calendar. The details of that event will be determined by the algorithm, which is finalized yet. It's the algorithm that will place the event somewhere. It'll find space for the event in the user's Google Calendar. Alright, so we still need to be able to authenticate any user that logs into the app and authenticate their Google Calendar and give them read-write access.
Okay. So I had the login page. I still have to like change it up to front ends, and then we also have to
Basically, that's we talked about everything else.
yeah, we did it. Yeah, so that yeah, but then for 2 more points outside, I had to figure out the algorithm, but the time slot, our calendar, and then I was trying to make the more natural.
All right, cool. So with that, we're done. If there's someone that hasn't presented, let me know. But otherwise, we're done.